This is a very conceptual example. And again, this is one of those problems that kind of separates the people who are getting a 3, a 2, or a 1 on the AP test from those who are going to get a 4 or a 5. What we've got is we're being told that we've got a continuous function on a closed interval, and then we're being told some information about that function. So we've got some derivative data right here, and then we have some second derivative data right there. And based upon just that information right there, they want us to know which of the following could be a table of values for the original function f. So we don't have an equation to work with, so we're not able to get back, take antiderivatives to get back to the original equation. We're really working with some very conceptual stuff here. So let's see what that given information can tell us. So starting with this second derivative here, it's telling me the second derivative is negative. So a negative second derivative tells me that my graph is concave down. Then I know that what's going on here is I've got f prime of 4 is equal to 3. So that's a positive first derivative, which means my graph is headed up and increasing. So on some concave down graph, I know that I have the slope of a line right here, that my f prime of 4 is equal to 3. So the slope at that position right there is equal to 3. And then I look at my tables and I'm like, what can I find out from those table of values? Well, I can find out other slopes that are going on here. And what they want us to be able to see about this is, if you think about it, you notice that all of these graphs or all of these tables here, the middle value is 4, that point that we're talking about on the graph. So all of these have a middle value of 4 right there. Then I can find the slope between 2 points really easily. And so when I look at my concave down shape and I sort of draw another slope off of it right there, what I can see is that this slope, I don't know what it is, but that slope right there is always going to be less than 3 in this situation. Then when I've got a concave down graph, my slopes are getting smaller as I move along from the left to the right. That also tells me that before that point there, that my slope before that has to be bigger than the slope at my point. So the slope down here, the slope before it needs to be bigger than 3. So what I now can do is I can go to my tables, and I am looking for the table that gives me a slope before 4 that is greater than what they said it was, greater than 3. And I'm looking for the table that has a slope that comes after 4 that is less than 3. So this is just going to be a bunch of slope equations here. So we're just doing the classic y2 minus y1 over x2 minus x1. So the before is going to be the top two values, and then the after is going to be coming from the bottom two values. And all these tables have the same values. So we're just finding these two slopes and seeing which one gives us what we want. So if I work before, so this would be x1, y1, x2, y2. Doing the before, I get y2, 7 minus y1, 3.5 over x2, 4 minus x1. 7 minus 3.5 is going to get me 3.5 over 1, so I get 3.5. So that is the slope before. And that fits because that is greater than 3. And now I need to go and find the slope after. And it needs to be less than 3. It can't be equal to 3 because the graph is concave down. So the concavity tells us that it continues on that shape, which means that the slopes are going to keep getting smaller and smaller. So after, I'm now looking at x1, x2, and this would now be y1 and y2. So finding that, I would get 10 minus 7 over 5 minus 4, which would get me 3 over 1, which is 3. So it can't equal 3. It has to be less than 3 because of the concavity here. And so you would know that the first table doesn't work. And you just keep coming through and playing the same game. So on this next one, the before, y2, 7 minus y1, 4 over x2, 4 minus x1, 3, we get a 3 out. So the before, again, there's no equals here. That slope has to be strictly greater than 3. And since that's equal to 3, that's not what we want either. So B is off the table right now. Moving on to C, we go and we say, okay, before. So again, y2, 7 minus y1, 3.5 over x2, 5, or excuse me, not 5, x2, 4 minus x1, 3. So we get 3.5 over 1. So before is 3.5. That works. 3.5 is bigger than 3, and so that's going to be okay on that one. And then after, I would be doing the second. I would do 9 minus 7 over 5 minus 4. That is going to get me 2 over 1, and so that's 2. 2 is less than 3, so that fits there. So right now, C is looking like my good graph. And if we just continue down the line, you're going to see that none of the other tables are going to give us what we want. The slope on this one before would be 3. That's not what we want, so that's not a good answer. It can't equal 3. And then if I do the last one here, I would end up with, what would that be, 1.5? And so the before on this would be less. And so we need it to be bigger, so that one definitely wouldn't have been it anyways. So the option here is option C. So this is a very conceptual question. They told us what the concavity was, so that told us that we needed to look at a concave down shape. And when we looked at a concave down shape, when we're in the increasing portion of it, when our derivative is positive, we're over here at some random point. You just give yourself something to reference. And the one thing we know is that the slope at every point after it would have to be smaller than it, and the slope at every point before it would have to be larger than the point that we were actually looking at. And the only one that fits that is option C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.